Algebra 2, 6.3, Simplify Complex Rational Expressions. If you haven't seen the previous videos for Chapter 6, you might become lost or confused, and there's links in this video's description so you can just click on them, okay? A rational expression is the quotient of two polynomials. A complex rational expression has a rational expression in its numerator, its denominator, or both. In the first one, we can see that it's got this in the numerator, this one's got it in the denominator, and this one's got it in both the numerator and denominator. And if there's any negative exponents above or below the fraction bar, it'll make a complex rational expression. Do you remember from Algebra 1? I'm going to have a link to 5.1b, the video from Algebra 1. When we learned about the rule of negative exponents, we can turn this into a positive exponent by writing it as a fraction. See? So, let me show you this real quick. This can actually be read as the quotient. That's where this purple fraction bar is coming in so that we can tell it from the other ones, because there's going to be so many fraction bars in this video. So I made them all purple. So this is the quotient of 5 and x and the quotient of x and y. Okay? So we're going to simplify complex rational expressions, and there's three ways I'm going to show you how to do this. The first way is we're going to find the LCD, that least common denominator of all the denominators in the expression, and then we're going to multiply both the numerator and denominator by that LCD, that least common denominator. The second way I'm going to show you is we're going to simplify the numerator and denominator separately, then treat the result as division. And the last way I'm going to show you is we're going to convert any negative exponents into rational expressions first, then we're going to be simplifying the new complex rational expression. So let's look at this first way, this LCD way, okay? This is method 1. So we've got this complex rational expression, and the LCD is x squared. So what we're going to do is we are going to multiply this entire complex rational expression by the LCD, x squared over x squared. We're going to use the distributive property and distribute it in to the numerator and denominator. Now, remember, we subtract exponents to simplify. That was the quotient rule. That's Algebra 1, 5.1b, and dividing using exponents. So this x underneath this x squared, we're going to subtract, aren't we? So we're going to get just an x. If you have x squared and you take away an x, you're just going to have an x. And for this one, that's a 1, isn't it? X squared over x squared makes a 1. So now this is our new complex rational expression. Actually, it's just a rational expression, isn't it? We took the complex part out of it when we did the quotient rule, didn't we? Now we can factor the numerator and denominator. This x squared is an x times x, isn't it? So we can write this as an x times x plus 1, and the denominator can be factored as x minus 1, x plus 1. And if you've seen the previous videos from Algebra 2 in this chapter, 6.1a and 6.1b, we did this. We can remove a 1 here because they both have an x plus 1, see? We factor the rational expression, removing the 1's to simplify, and all we're left with is x over x minus 1. See that? All right, let's try the second method. That's the one where we're going to simplify the numerator and denominator separately and then treat the result as division. So this is our big complex rational expression. You can see my purple fraction bar to separate it. Okay? We're going to be factoring the numerators and denominators. So this x squared minus 9 factors to an x plus 3x minus 3. This x squared plus 5x plus 4 factors to an x plus 1, x plus 4. This x squared plus 6x plus 9 factors as an x plus 3, x plus 3. And this x squared minus 1 factors as an x plus 1 times x minus 1. See? Now, if you saw the previous videos, you know what's going to happen with this orange and this green. We're going to multiply by the reciprocal, and that was from video 6.1c, and that link is in this description. So, we're going to flip this around. This was our big denominator in the complex rational expression. We're going to flip this around so it's denominator is its numerator, and its numerator is its denominator. It's going to be a reciprocal, see? So now the orange is on top and the green's on the bottom. And now, instead of dividing this by this, we're going to multiply this by this reciprocal, okay? So I'm going to write it this way because we're multiplying by the reciprocal, and we flipped this one entirely around. And what we get is some 1s, don't we? Look at, there's an x plus 3 here, and there's an x plus 3 there, okay? There's an x plus 1 here and an x plus 1 here. We can rewrite this whole thing to factor the rational expression and remove the 1s. Again, that was from video 6.1a and 6.1b. And what we're left with is just this part. And we're done. See? All right, so the third method was converting any negative exponents into rational expressions first and then simplifying that new complex rational expression. So here we go down here, and we're going to simplify this complex rational expression using that third method. So if you see, we have a negative exponent here, we have a negative exponent here, and we have a negative exponent there. We can rewrite and convert the negative exponents into rational expressions. So this becomes a 1 minus 3 over a. See? Because we have a whole number 3, it would be written as a 3 over 1, wouldn't it? And then because of that negative 1, it would be 3 over a. And it's going to be over, here's our fraction bar, this is going to turn into a 2a, and that's going to turn into a 3 over a squared. See? So now this is our new complex rational expression. We're going to look for the least common denominator. We've got an a and an a squared, so the a squared is going to be our LCD. Okay? So now we need to multiply this whole thing by a squared over a squared. Okay? We're going to distribute that a squared in for the numerator and denominator, and we're going to get a squared minus 3a over a squared minus 2a minus 3. We factor this, we get a times a minus 3 over a plus 1 times a minus 3. And you can see we can remove a 1 again, can't we? We've got the a minus 3 over a minus 3. And all that's left is an a over a plus 1. And it's simplified. Okay? Now I know this can be really confusing, and it'll be especially confusing if you haven't seen these previous videos. Because we talked about this, and we're slowly taking steps and learning all of this. So without seeing those previous videos, you could become very, very lost. Okay? So there's links in this video's description. So 3 is a rational expression as a 3 over 1, isn't it? So if someone says, is 5 a rational expression? Say, yeah, it is, because it could be 5 over 1. Look at this square root of x. Well, that isn't a rational expression because it's not a polynomial or the ratio of a polynomial. X to the negative second power is a rational expression because we can rewrite it as 1 over x squared. See? Our next video is 6.4, and we're going to divide a polynomial by a monomial. All right? And I'm going to put this video in the Algebra 2 playlist so you can study and catch up and review. And I'm going to have links to the Algebra 1 videos that are similar or helpful. 10.10 talks about complex rational expressions, and 5.1b talks about the quotient rule. All the Algebra 2 videos from this current chapter that are going to be helpful are going to be in this video's description also. All right? So everything is at your fingertips. It's just up to you to click on them and watch them. All right? So if you're really confused, go back to 6.1a, watch all of these videos, and then watch this one again, and you'll probably be fine. Okay? I hope you're doing well, and I'll see you next video. Bye.